In this tutorial, we will look at some common questions in the topic of sorts. But let us first do a quick review of the chapter. The important parts of the chapter would be the solubility rules. So you need to know the 5 solubility rules. That is a prerequisite before you even go on to the later parts. Because if you cannot predict the solubility of a salt, there's no way you can know the method and so on. Next, we need to know the method for preparing each type of salt. And once we can put a method to a salt, next thing we need to know would be the starting reagents, the recommended or the suitable starting reagents in each method. And lastly, the procedure or the key steps for the preparation of each salt. For the first question, we are looking at solubility rules. So the question states that when you mix 2 solutions, which one would produce a precipitate? So a precipitate is actually an insoluble salt. And the important thing to know in this question is that when you mix 2 solutions, the ions are going to be mixed together. So in order to know which one produces an insoluble salt, the approach will be to interchange the ions in the 2 solutions. For example, in option D, I'm going to interchange the ions. So we're going to end up with sodium chloride and barium sulfate. So the question that you need to ask yourself is this: is any of the salt insoluble in water? And if you know your solubility rules well enough, immediately you would recognize that barium sulfate is insoluble in water. So that means that D is the correct answer. The next 2 questions, we are looking at the different methods for preparing salts. In the question at the top, we are trying to prepare magnesium chloride. So for magnesium chloride, it is a soluble and non-spar salt, meaning the suitable method for preparing the salt would be your excess method, and it will involve an acid plus an insoluble solid. All right, so let's go through the options. Now, colors of salts is not really related to this chapter, but when you have salts formed that are not transition metals, or rather if the salt doesn't contain a transition metal ion, it's usually not colored, so it appears white when solid. So magnesium is not a transition metal, so the salt will be white. It is soluble in water, so immediately we would know that C is the correct answer. But again, the method of preparation would be your excess method, where we add excess metal to your acid. In the bottom question, we are looking at the method of titration. So for titration, if you can recall, titration is for the preparation of soluble spar salts. So the salt that you are preparing must be soluble, and immediately we would know that D is the correct answer. The next few questions are related to that of starting reagents. So for the question on top, we are looking at preparing lead 2 chloride. The question tells you already there is an insoluble salt, so we need to use the precipitation method, and the starting reagents would be 2 solutions. So in this question, the correct option would be the one where we have 2 solutions or 2 soluble substances. For A, lead 2 carbonate is insoluble in water. Lead metal insoluble in water. C is correct. Why? Because nitrates, all nitrates are soluble in water, all acids are dissolved in water. So C is correct. Next, D, lead-2 oxide. We have learned that only your spar oxides are soluble in water, so lead-2 oxide is also insoluble in water. For the bottom question, we are looking at preparing lead-2 sulfate. Again, lead-2 sulfate is an insoluble salt. So insoluble salt, like above, we need to use precipitation method. We need to mix two solutions. So one of the solution has been given, sulfuric acid, and the other one, or rather the correct option, must be one that is soluble in water again, and the answer is similar. It's just lead-2 nitrate, because all nitrates are soluble in water. Next, we will look at questions related to the procedure for preparing each salt. So let us take a look at the salt that we need to prepare. Silver chloride, based on your solubility rules, is insoluble in water. Therefore, we need to use precipitation method, and the suitable starting reagents will be two solutions. Now for this question, the two solutions have been given to you. So silver nitrate and dilute hydrochloric acid. So all you need to do is to describe the procedure. So for precipitation, that's the easiest. You just need to mix the two solutions, filter to obtain the residue, wash with a bit of cold deionized water, and dry by letting it dry in air or by pressing between pieces of filter paper. So this is the mark scheme provided by Cambridge. I think it's good for you to look through it to know what are some of the key steps or key marking points for this method. Next, we are looking at the preparation of magnesium chloride. Magnesium chloride is a soluble non-spar salt. So we are looking at the excess method, and a suitable starting reagent would be an acid plus excess of an insoluble solid. So name the acid and the insoluble base. In this case, they specify that they want a base. So to prepare magnesium chloride, we need to react hydrochloric acid with a suitable base. The base would be your magnesium oxide. In our syllabus, we learned that bases are metal oxides and hydroxides. So we can also use magnesium hydroxide. Now, since the question requires you to name the acid, so please be careful not to make the careless mistake of writing the formula instead. For part 2, you're supposed to describe the procedure. So in the excess method, we need to add excess of your magnesium oxide to your hydrochloric acid. You can warm the mixture and until no further reaction is observed, or until some magnesium oxide remains undissolved. Then you need to filter to remove your excess magnesium oxide, and then you need to heat the filtrate until saturated. You need to cool and allow the crystals to form, filter to obtain the crystals, wash with a bit of cold deionized water, and dry by pressing the crystals between pieces of filter paper. So again, this is the mark scheme given by Cambridge. You might want to look through it and to know the key steps that they are looking for. But once again, the mark schemes can vary from paper to paper. So it will be good for you to write down all the steps that you can recall. Lastly, we are looking at the preparation of aqueous ammonium nitrate. So ammonium nitrate is a soluble and a spar salt. So we're going to use your titration method, and the suitable starting reagent would be an acid and an alkali. So over here, the question requires you to start with nitric acid. So we will be titrating nitric acid with aqueous ammonia. So for the titration method, there are two different stages. First stage is that we titrate nitric acid with aqueous ammonia with an indicator. So the indicator would tell us the volume of aqueous ammonia needed to reach the endpoint or the equivalence point. So after that, we repeat the titration without the indicator, and then we add the recorded volume of aqueous ammonia, and then we perform an evaporation procedure, which is your heat until saturated, cool and allow crystals to form, filter to obtain the crystals, wash with a bit of cold deionized water, dry by pressing between pieces of filter paper. So this is the mark scheme given by Cambridge. So notice that you do not need to really write in very detail, like pipette 25 centimeter cube of acid and so on. So they are looking at very broad key steps in the preparation rather than the individual steps as we will write for a planning experiment.